Channel and coaching center. So today I'm going to explain your 12th standard physics 8th chapter, that is electromagnetic waves part 2 video. So last video I explained about the Maxwell's theory, his formula, and the Ampere's law, and Gauss law, and the Faraday's law, and Marconi, who said that who made electromagnetic waves can be used in communication also said. So let's continue from there. So let's come to the next. After that, the next topic is nature of electromagnetic wave. So in Maxwell said that the electric and magnetic fields in electromagnetic waves are perpendicular to each other. He said that. So the electric field inside the plate of capacitor is directly perpendicular to the plates, he said, and the magnetic field that gives rise to via the displacement current is perimeter of a circle parallel to the capacitor plate. So B and E is perpendicular to this case. This is the general feature. He said that electric field, magnetic field and electric field are perpendicular to each other. And some of the example of electromagnetic wave propagation along to the z direction, and the z is coordinate at the given time t, and the magnetic electric field ex is along the x-axis and varies simultaneously with z at a given time, and the magnetic field by is along the y-axis and again varies simultaneously with z. And by that the electric and magnetic field ex and by are perpendicular to each other, we can say. As you know, the magnetic field and electric field both are perpendicular, he said. So therefore ex is equal to e theta by sine, and by is equal to b theta by sine. So k is equal to 2 pi by lambda. Next he said that w is equal to ck, where c is equal to 1 by root uo by eo. So 2 pi v is equal to c 2 pi by lambda, or we can say that v by lambda is equal to c. So bt is equal to e0 by c. So we have make remarkable on some features of electromagnetic wave. So some features of electromagnetic wave: they are self-sustainable oscillation of electric and magnetic field in free space or vacuum. So they are self-sustainable in space and vacuum, the electromagnetic waves, and they differ from all other waves we have studied in our lower classes. And the vibration of the electric and magnetic field also happens, and sound waves in air or longitudinal waves of compression and refraction, and transverse waves on the surface of water of compression and refraction. Transverse waves consist of water movement up and down. So if there is transverse waves in water, it consists of upper and lower movement. So transverse wave you have learnt about wave chapter in your 11th class, and also many other things they have given. So next is the so which responds to electric and magnetic field just as an elastic medium does. They called as the medium ether. So that respond to the electric and magnetic wave in like electric medium, like a medium elastic medium does. If they respond, then it is called as medium ether. And they were convinced of the reality of this medium, so that there is even a novel called The Poison Belt by Sir Arthur Conan Doyle, who wrote the book on this. Next, they have given the velocity of light becomes v is equal to 1 by root ue is the velocity of the light become, and magnetic permeability u is denoted by u, the permeability of magnet. So next is electromagnetic field of different wavelength, that this velocity is the same and independent of wavelength to within a few meters per second out a value of 3 into 10 to the power 8 meter square. So the consistency of the velocity of centimeters waves in a vacuum is so strongly supported to the experiments. Actually value is so well known now that this is used to define the standard of length. So the value is now well known that it is defined, the values are defined to explain the standard of length. and earlier measurement of C using earlier units of length converged to a value about 2.9979246 into 10 to the power 8 meter square. So Hertz not only showed the existence of electromagnetic wave but also demonstrated that the waves which has wavelength 10 million times that of the light wave could be diffracted, refracted and polarized. Means the Hertz does not give simple example about the electromagnetic wave. We also said that the wavelength that has more wavelength than like 10 million, it can also reflect, we also said. And the fact of electromagnetic wave or polarized can be easily seen in the response of in the radio stations we can see, and in the signal antenna there we can see these are used more and more. And also, so thus the illustrates the fact that carries energy and momentum. Since that carries momentum, and electromagnetic waves also exerts pressure, and that pressure is called as the radiation pressure. So what is radiation? Means electromagnetic waves also exerts a pressure that is called as radiation pressure. And next is the transfer to surface in time. T is u, and it can be shown as magnetic of the total momentum delivered to the surface is P is equal to u by c. This is the formula we use. And also, so after that in 1903 scientists Nicholas and Hull succeeded in measuring radiation pressure of visible light. So they were succeeded in finding the pressure of visible light. And also the radio or TV signals from broadcasting station carry energy. They also have some energy. Light carries energy from the sun to the earth, thus making life possible on the earth. Like that only the TV and radio stations carry some energy. They said next is the sums you have to solve based on this. The sums based on this you have to solve. So let's come to the next topic, that is electromagnetic spectrum. So these are the sum you have to solve by using the formulas till now you have learned. Next is electromagnetic spectrum. At the time of Maxwell predicted that electromagnetic waves are there. So the only familiar electromagnetic waves were visible light waves. The visible light waves were the only electromagnetic waves that were found at that time. And next, in the 19th century, they discovered X-rays and gamma rays had been discovered in the 19th century after the Maxwell visible light ray discovered. And X-ray, gamma ray, radio waves, ultraviolet rays, ultrasonic waves, and also there is a and also the classification of EM waves according to the frequency of electromagnetic spectrum. There is no sharp division between one kind of wave and the next. So there is no change, sharp different division. There is nothing. The all are little bit similar only. The waves are similar. See here in this you can see all are similar only. There is little bit change. That's all, not very different or different divisions they are. Next is radio waves. Let's know about one by one. The first wave is radio waves. Radio waves are produced by the accelerated motion of charges in conducting wires. So in conducting wires, by the motion of charges, the radio waves are formed, and they are used in the radio and television communication system. And they are generally in a frequency range of 500 kilohertz to about 1000 millihertz. And AM, the amplitude modular band is from 530 kilohertz to 1710 kilohertz is the range it is, and higher frequency is the 54 millihertz are used in shortwave bands. In shortwave band 54 millihertz. And this is about the radio waves. Next is microwaves. So in 15th chapter I have explained about there, you can see that. So microwaves, short wavelength radio waves with frequency in the gigahertz, that is GHz, and range, and are produced in special vacuum tubes called magnetrons and other things. And due to their short wavelength, they are suitable for the radar system. So in the radar system, navigation system, they are used. And Microwave ovens or domestic application of these waves, and in such a ovens the frequency of the microwaves is selected to match the resonant frequency of water molecule. So the frequency wave is equal to the water molecule waves. And so this is about the microwaves. Next is the infrared waves. So infrared waves are produced by hot bodies and molecules. This band lies adjacent to the low frequency or long wavelength end of the visible and spectrum, and infrared waves are sometimes referred as the heat waves. It is referred as heat waves because of heat energy it happens. Next is visible rays. So it is the most familiar from the electromagnetic waves. It is the part of the spectrum that detected by a human eye. So by human eye also we can see that, and it runs from about 4 into 10 to the power 14 hertz to be about to 7 into 10 to the power 14 hertz, or wavelength of 700 to 400 nanometer is the wavelength it is. So that also comes to our eye. And ultraviolet rays. Next is the covers wavelength ranging from about 4 into 10 to the power minus 7 meters down to 6 into 10 to the power minus 10 meters. Ultraviolet radiation is produced by special lamps of very hot bodies, and the sun is an important source of ultraviolet ray, but fortunately most of it is absorbed in the ozone layer in the atmosphere. At an altitude of 40 to 50 kilometers we can observe the ultraviolet rays, or it is also called as UV rays, that is harmful for our skin and it may cause skin cancer. And as you know, ozone layer in the atmosphere plays an protective role, and hence it is depletion by chlorofluorocarbon is a matter of internal concern. So it is very much tension because of CFC. The ozone layer is getting there. You can see in the new few months they are saying there is some holes on ozone. You may hear it about that. So this is because of CFC. You have learned in your lower classes. Next is X-rays. So beyond the UV rays, the electromagnetic spectrum lies in the X-ray region. So we are familiar with X-ray because of its medical application. So as you know, medical application, because in medical they use them when they say X-ray in the medical, they do scan if there is a problem in your leg bone, marrow, or bone is broken, or anything they use in medical. They use X-ray. So one common way to generate X-ray is to bombard a metal target by high energy electron. So by energy electron we should bombard or we should target it, and X-ray are used to diagnostic tool in medicine and as a treatment for the certain forms of cancer. And because X-ray damage or destroy living tissues or organisms, care must be taken and avoid unnecessary overexposure. So X-ray may causes damage to tissue or organisms, so they should be taken a care while doing the X-ray. And next, the final topic of this chapter is gamma ray. So they lies in the upper frequency range of the electromagnetic spectrum and have high wavelength of from about 10 to about 10 meters to less than 10 to the power minus 14 meters. And this is the high frequency radiation is produced by nuclear reaction and emitted by radioactive nuclei, and they are used in medicine to destroy cancer cells. These gamma ray are used in medicine to destroy the cancer cells that may cause cancer. They are that cells to destroy that the gamma rays are used. So this was your chapter electromagnetic waves. So here you have learned about the Maxwell's theory and the Ampere Maxwell theory and Faraday's theory, and the next Marconi, and many other things in this chapter you have learned. And you have learned about X-ray, gamma ray, UV ray, and radioactive rays, and many other rays you have learned in this chapter. So I think you understand this chapter. So okay friends, like the video, comment on my video, and subscribe my channel and coaching center for more video. I will explain the next topic in my next video. So till then, take care, have a nice day. Bye my friends.